Hello and welcome to this video on the basics of two-dimensional arrays. So I usually visualize 2D arrays in one of the following two different ways. The first one is as a simple table of values. So as you can see here, the reason why it's called two-dimensional is because it takes up a flat sheet of paper. It has m rows and n columns. So in this case, you're seeing a 3x3 table. So it is also a 3x3 two-dimensional array. Now, if you try putting brackets around each row, so that every row is like a one-dimensional array, then you can see that if we deleted the changing of rows so that we put them on the same line, we don't really lose any information, because the numbers in the first brackets we would know came from the first row. So no information has been lost. And if we now put brackets around these, then we have basically a one-dimensional array where every element is also a one-dimensional array. So that's the second way of thinking about 2D arrays. They're the same as one-dimensional arrays, except every element is also an array. So I've made a short code section on how to create a two-dimensional array. So let's make one that has integers as its elements. So its variable type is called int square brackets, indicating that it is a two-dimensional array. Now I named my variable basic, and this is the most straightforward way of declaring a two-dimensional array. You literally just type out what the array is. So you see, it is just a normal one-dimensional array, except every element is also a one-dimensional array. So to see whether this basic, which we just declared, behaves as we want it to, we can try printing out each element. So let's start with its top left corner. So it's the 0th row, 0th column, and we have 1. Now if we move on to the first column, then we have 2, and so on. 3. So yes, it behaves as we want it to be. Now, say we want to make an empty kind of 2D array. We don't know what each of its elements are, so we can't really write it out in this straightforward way. Then what we could do is just say, okay, I want to make a new two-dimensional array. Except there's one detail that you have to establish before you create an array, and it is the number of rows and number of columns. This has to be known before you declare the array. So let's say I want it to have 3 rows and 3 columns. Then you can let's see what we have just created. So if we try printing out the top left corner of this basic 2, which we just declared, we'll see it's 0. And try the next element, and it's still 0. And it's still 0. So the conclusion is, when we create a new array using this new int array method, then it will be automatically filled up where every element is 0. Now, say we tried making it a string array. And now let's try printing out the top left corner. It will be null. So, no information. And if we made it a double, then it would be 0.0. So that's pretty cool. Now what if we want to change the value in the 2D array to something that we actually want? So let's say we want to change the top left corner. Instead of 0, we want it to be 1. So let's make this back into an integer array. So what we can do is we say that I want the top left corner of basic2 to be 1. Now let's try printing out the top left corner again. And indeed it's 1. Now you've just seen how I print out individual elements in an array, but what if I want to print out the entire array? Well, we've just done that. We've run the program for printing out one element for the top left corner, then we went on to the next element, then the next. So essentially, what we are doing is a nested for loop. So we are saying that for every row, I want to go through every column so J is now the column number, and print out the element. So print out array at I row and J column. So let's try printing now basic, and indeed we have 1, 2, 3, 4, 5, 6, 7, 8, 9. But we don't want to lose information about where the rows change. So we could say after we finish each row, system.out.print a comma, or print 9 a comma. So now you'll see that the rows change. Now in printing out the entire array, we've basically trespassed each element in the array and did something on it. So we didn't have to print it. What we could do is we now have the power to examine every array. So every element in the array. So for example, if I had the same code, except, oops, sorry. So let's make another and call it count even. And we say for every row in every column, we check if this element is even, and if it is even, we want to count how many even numbers there are. So if it is even, then we add 1 to our counter, and in the end we print our counter, and let's see what happens with basic. So we found 1 in this case in the first row, and we found 2 in the second row, so for a total of 3, and then we found 1 more in the third row. So in the end we have 4 even numbers. Indeed we have 2, 4, 6, and 8. And that is all the basic operations for a two-dimensional array.